Okay, we're going to do simple equations and word problems. And this is going to involve solving first-degree equations, including fractional equations, and checking our solution. It's going to mean that we're going to interpret and solve word problems that lead to first-degree equations. We're going to solve financial word problems. We're going to solve word problems involving mixtures, but we are not going to do statics. Even though word problems tend to be difficult, it is a very useful skill that employers need you to have, because this skill allows them to express what they need and for you to turn that into equations and so forth, solve those equations, and be productive. Section 3-1 of the text has to do with solving first-degree equations. This one down here is a first-degree equation because x is raised to the first power. What we have here, because x is raised to the 2, this is a second-degree equation. Now, the thing that determines an equation is an equal sign. Otherwise, we just have an expression, and we saw that before. So what's on the left-hand side of the equation balances what's on the right-hand side of the equation. Now, second-degree equations are difficult to solve compared to first-degree equations. So let's start with baby steps and start working with our first-degree equation and work up to second-degree equations later. So if we say x subtract 5 equals 0, this is balanced with this. Now what we can do is to keep the balance, if we want to add, say, 5 to this side, we also have to add 5 to this side. And by adding 5 to the left side and 5 to the right side, the balance is maintained. Now we can rewrite this as x because minus 5 plus 5 is 0, so x equals 5. And this becomes the solution to a very simple first-degree equation. Now, to check out and validate that that's true, what we have to do is take a look at the left-hand side of our equation and substitute this in. X subtract 5, let's take a look at the left-hand side, and if we substitute the 5 in, what that is 5 minus 5, which is equal to 0. So the left-hand side of our equation is equal to 0, and also our right-hand side of our equation is equal to 0, so we've just validated that our solution x equals 5 is correct. Let's take a look at working out this equation and solving it. So if we take 2x plus 3 is equal to 9 minus 4x. Now what we want to do is bring this over to the other side. In order to do that, we can add 4x to this side and add 4x to this side to maintain the balance. And if we rewrite this, this is going to give us 2x plus 4x plus 3 equals 9. And if we combine terms, this is 6x plus 3 equals 9. Now if we want to get the 3 on the other side, we would say 6x plus 3 minus 3 is equal to 9 minus 3. Let's carry this on over here, and this gives us 6x equals 9 minus 3, which means 6x equals 6. And to further this, let's just continue on over here. 6x equals 6. If we divide both sides by 6, we get our final solution. Let's put that up here. We divide out our 6's here and this. We get our final solution as x is equal to 1. Now that we have our solution, let's substitute it into the left side. So that's 2x plus 3 on the left side. So if we substitute in, it's 2 times 1 plus 3 on the left side, which is equal to 5. Let's take a look at the right side. That's 9 minus 4x, which is equal to 9 minus 4, which is equal to 5. So this is our left side, this is our right side, and we can see that they balance, so x equals 1 is indeed our solution for this problem. Let's take a look at doing example 6. Instead of using color, to determine the difference between these two, I'm just going to do it all in one color. So on the right hand side we have 3x minus 5. On the right side of the equation we have x plus 1. What we want to do is get rid of the minus 5 on the left, so we're just going to add 5 here and we're going to add 5 there. What this ends up being is 3x on the left side is equal to x plus 6. What we want to do is get this x off this side, this x away from this side, so we're going to say 3x minus x is equal to x minus x plus 6. So 3x minus, let's continue on down here, 3x minus x equals 6, which is really 2x equals 6. And we can divide both sides by 2. And what we get is x is equal to 3 as our solution. Now, we're not finished yet because we have to check it. So on the left side, we have 3 times x, and x is 3, minus 5, which is equal to 9 minus 5, which is equal to 4. On the right-hand side, we substitute in x plus 1, which is 3 plus 1, which again is equal to 4. So this becomes our proper solution. Let's take a look at example 7, which is this equation here. So there's our equation there. So let's expand out this term. We get 9x plus 3 minus 6 on the left side. On the right-hand side, we get 5x minus 10 plus 15. So this evaluates to 9x minus 3 equals 5x plus 5. If we get rid of the 3 on the left side, it's 9x minus 3 plus 3 equals 5x plus 5 plus 3. This gives us 9x is equal to 5x plus 8. And if we say 9x minus 5x, to move the 5x over, is 5x minus 5x plus 8. We get that this is 4x is equal to 8. If we divide both sides by 4, we get x is equal to 2, which is our solution. But to check our solution, we have to substitute this back into the left side and the right side and make sure they're the same. So this is going to be 3 times 3 times 2 plus 1 minus 6. So this is equal to 6 plus 1 times 3 minus 6. So that's 3 times 7 is 21 minus 6, which is equal to 15. On this side, this is going to be 5 times 2 minus 2 plus 15. 2 minus 2 is 0, so our right side is also 15. So this becomes our solution. Let's take a look at solving fractional equations like example 8, where we have x over 3 minus 2 equals 5. Now given this equation, one of the first things we have to do is move the 2 to the other side. So that's going to give us x over 3 minus 2 plus 2 equals 5 plus 2. This keeps our equivalence. So this means x over 3 is equal to 7. Now to get the x by itself, we're going to have to multiply 3 times this side and 3 times this side. So this is going to cancel out this, and we've got x is equal to 21. So that is our solution. Let's take a look and see if it's going to work when we substitute it into our original equation. So on the left side here, this is going to be 21 over 3 minus 2, which is equal to 7 minus 2, which is equal to 5. And that's exactly what we have on the right side as well. So this is our solution to this problem. Let's take a look at a little more complicated one, for example, 9. This equation right here. And let's see how we go about solving that. Let's look at this, which is a little more complicated version of what we just did. One of the things we're going to find is we have x over 2 and x over 3. What we want to do is get x by itself. And one of the things you'll notice that 2 and 3, if we multiply them together, are 6. So if we multiply both sides by 6, we can clear the 2 and the 3. Let's see how that works. So let's multiply all the things through by 6 times this and 6 times this. So this is going to give us, if we look, 6 times x over 2 is going to give us 3x plus 6 threes is 18. And if we divide these out, we're going to have equal to 2x. Once we have this, we can very simply say 3x plus 18 minus 18 equals 2x minus 18. So that's 3x equals 2x minus 18. And we say 3x minus 2x is equal to 2x minus 18 minus 2x. We end up getting x is equal to minus 18. Now, to make sure that this works, we're going to have to do our check. So let's substitute in. So we have minus 18 on the left side over 2 plus 3. This is equal to minus 9 plus 3, which is equal to minus 6. That's on our left side. On our right side, we have minus 18 over 3, which is equal to minus 6. Since both sides are equal, this is a valid solution. Let's take a look at example 10 and try and solve it. And this is what we have as our equation. Let's see how we do that step by step. First of all, we have to be very careful with the order of operations here. Now, as the last one showed, we have a denominator of 2 and a denominator of 3, so it makes sense to multiply through the whole left and right side by 6. So this would be 6 times 3x minus 5 all over 2 equals 6 times 2 bracket x minus 1 over 3 plus 4. Now I think you can see that we can divide 2 into this 3 times, which makes our left side here 3 times 3 is 9x minus 15. Now this is where you have to be a little careful. So let's do these two terms separately. This is 6 times 2x minus 1 over 3 plus 6 times 4. And if we figure this out, this is going to be again 9x minus 15 equals, now we can divide the 3 and 6, so we get 2 times 2 bracket x minus 1. Because we can divide 3 into here and get 2. And then we have to add 6 fours is 24. So this becomes 9x minus 15 equals 2 times 2 is 4x minus 2 plus 24. So this is 2 times 2x minus 2 plus 24. So this becomes 9x minus 15 is equal to 2 times 2x is 4x minus 4 plus 24. So if we want to get the x's on the left side, we say 9x minus 4x minus 15 is equal to 4x minus 4x plus 20. So that gives us 5x minus 15 is equal to 20. If we continue on, we can say 5x minus 15 plus 15 is equal to 20 plus 15. So we got 5x is equal to 35. If we divide both sides by 5, we get x is equal to 7, which is our solution. Next thing we have to do is check to make sure the left side and the right side match up. To check out our solution, let's take a look at the left side. And this is 3 times 7 minus 5 over 2, which is 21 minus 5 over 2, which is 16 over 2, which is equal to 8. Let's take a look at our right side. This is 2 times 7 minus 1 over 3 plus 4. This is 2 times 6 over 3 plus 4. I think we can see that this cancels out, and that gives us 4 plus 4 is equal to 8. So since both sides are equal, the solution works. Let's take a look at example 11. Solving this is not easy. So let's do it step by step and see if we can figure out our answer. Now with something this complicated, what we want to do is let's simplify the left side, simplify the right side, make them equal, and then do the solution. So let's take this first and simplify this. So let's put 3 square bracket and then figure out from the FOIL rule that this is x times 2, so that's 2x. Outer is going to give us minus x squared, and then inner is going to give us plus 4, and then outer is going to give us minus 2x. So that's on our left side. So we can see here that we have 2x and minus 2x, so we can make this into 3 times minus x squared plus 4. And that is our left side almost simplified, so this is minus 3x squared plus 12. And this is what we have here for our left side of our equation once we've solved it down to there. Let's take a look at the right side of the equation. And this is going to be 3 square bracket, and let's use FOIL on this. This is going to be x squared minus 3x minus 2x plus 6, and then we're going to simplify this term, which is going to be plus 8x minus 6x squared. So we can see here that we can simplify this further. 3 bracket x squared minus 5x plus 6 plus 8x minus 6x squared. Put 3, multiply 3 by what's inside, so that's 3x squared minus 15x plus 18 plus 8x minus 6x squared. Oh, this is quite an exercise. We can say 3x squared minus 6x squared, so this is minus 3x squared. We have minus 15x plus 8x, so that's going to be minus 7x plus 18. So this is what we're going to have on our right side of our equation. This is going to give us minus 3x squared plus 12 is equal to minus 3x squared minus 7x plus 18. So I think you can see that if we add plus 3x squared to both sides, these go out, and we're left with 12 is equal to minus 7x plus 18. Now if we add 7x to both sides, 7x plus this plus 7x, I think we'll see that we have 7x plus 12 is equal to 18. And if we subtract 12 from both sides, we're going to see 7x is equal to 18 minus 12, which means 7x is equal to 6. And if we divide both sides by 7, we get our final solution that x is equal to 6 over 7. A lot of work to get here. Now the next thing we have to do is substitute it back in to show that this is indeed the right solution. Now instead of trying to figure out all of this left-hand side and right-hand side, I think you remember that we actually got it down to this when we simplified all terms. So our left side is 12. Let's see if the right side is going to equal that. So this is minus 7 times 6 over 7 plus 18. So if we take a look at this, we're dividing minus 7 by minus 7. So this is minus 6 plus 18, which is going to give us 12. So in this case, our left side and right side do match, and we are sure that this is the appropriate solution here. Now let's take a look at using other variables other than x. X is just a letter representing an unknown. So we should be able to solve an equation such as this just as easily as if we were using x instead of p. So let's take a look at doing that. Whether we use p as the unknown or x, it doesn't matter. The rules still apply the same way. Left side becomes 4p minus 12. On the right side, this becomes 3p plus 12 minus 5. So this becomes 4p minus 12 equals 3p plus 7. And if we want to get 3p on both sides, we can subtract 3p here and have minus 3p here. And when we do that, we get p minus 12 equals 7. And then we can say p minus 12 plus 12 equals 7 plus 12. So p is equal to 19. Now what we can do is, again, check. And so let's check the left side. So this is going to be 4 times 19 minus 3, which is 4 times 16, which is 64. On the right side, this is going to be 3 times 19 plus 4, and then we subtract 5. 23, and then we subtract 5. So this is going to be equal to 69 minus 5, which is equal to 64, which shows us that p indeed is 19. Sometimes, like in example 15 here, you'll be given an equation such as this, and you'll have a constant that isn't written as a number. It's going to be written as what they call a literal. And to actually solve this one for x as it says, what you have to do is subtract b from both sides. So you're going to get 3x is 5 minus b. And then when you divide both sides by 3, you're going to get x is equal to 5 minus b over 3. So without knowing b, you won't be able to come up with a final answer. But when you're given b, you can substitute it in and get the right answer. But this is the proper solution given this type of equation that has a literal or a constant in it represented by a letter.